I've been asked to continue with the explanations of the software part of the build. Seems as the build is evolving, more features are creeping into the plan. The feature needed for the project now is the use of the alert output, and with that there are a few more registers to set, and also some explanation of the two new functions I'll be using. So this is officially turned into a series. I've asked my friend to make the project elaborate enough that I can at least get 3 videos out of it, so he can have enough code explanation done on the Adafruit I2C library that he can refer back to it if he needs to. Okay, I won't go over the code from the first video again. I'll just explain the 2 new write functions I'll be using. And that will be, let's see right here, write 8. It has 3 parameters. Again, the device address, which is my device address is right there. The register, which this one will be T-high register, and the value I want to put into it in Celsius. Alright, and see the second function will be the write list function. That has 3 parameters also: the device address, the register, and for the third parameter it wants a list, and I'll go into that more a little bit later. Alright, so I'll just go to data sheet, and we'll talk a little bit about the high and low limit registers. Really all we have to write to is the first byte in these registers. Like the T-high register has 2 bytes, but I'll only really need to write to the first byte, because the first byte is like the integer part of the Celsius output. The integer is like a 1-to-1 relationship. There's no conversion needed. If you want 27 degrees Celsius, then that's what you plug into the third parameter of the function, decimal 21 or 27. The float portion isn't as nice and neat, but we're not using it anyway, so we'll just leave it at 0. And byte 2 would be the float portion, anything to the right of the decimal place. Alright, so we'll go to GitHub, and I'll explain a little bit about the second function, which is write list. And what we have here again is, device address, the register we're going to write to, which will be the T-low register, and a list. And the list, well, here I'll show you right here, is anything in square brackets. And since we want to send 2 bytes, I'm going to send 25 for my low limit into the first byte, and 0, which would be the float portion, into the second byte. Alright, these will set the high and low limits for the alert output. Okay, and let me see if I can find it here. Where is it? There it is. Okay, here's the graph. It'll show the normal operating range right in here, and it'll show the T-high limit and the T-low limit. But first there is another register I have to set, and that is the configuration register. That is, where is it? That is, here it is. Alright, I'm going to use the write 8 function to set a bit in the first byte of this register. This just sets the polarity of the output. So the alert output will be high when it exceeds the T-high limit, and then go low when it drops below the T-low limit. And that bit is the POL bit right here. And that's, like I said, that's just personal preference. If we go back to our program, we'll see right here, going to write 8 to, the device address. The configuration register is 1, and I'm going to put decimal 100 into it. The library will do the conversion and plug in, or conversion to binary, and plug the appropriate ones into the register, so the POL bit will be set, and we'll have the polarity output we want. But like I said, that's just my personal preference. Alright, if we go back to the graph here showing T high and T low, the way I'm set up now with the registers I've chosen, I'm right here in the TP101 alert pin comparator mode, and comparator mode, or POL polarity equals 1. The comparator mode is the default mode of the TMP102, but the way it'll work is normal output will be low, and you'll see the temperature swings here. As soon as that temperature reaches T high, my output will go high, and it'll stay high until temperature swings and trips the T low, and then go to low output again. And that's just the basic function of the alert output. Alright, let me get back here. I'll get out of this and run the program. Alright, there's Celsius, Fahrenheit. Here's the BeagleBone setup with the TMP102 temperature sensor. And I'm just going to put the iron close to it. See if I get it to trigger at high temp, which it does. Take it away, temperature goes down, and it goes out. So the alert output is working. Alright, I'll stop it there. I'm sure there's going to be a third installment coming, and I hope this has been helpful, and we'll see you later.